Hello everyone. So in this video we'll be learning about graphs. A graph can be represented. It's basically a collection of vertices and edges. So it's a collection of vertices and edges, and there are basically two types of graphs: directed graphs and undirected graphs. Directed graph is also called as digraph, and each node in a directed graph has either an in degree, has both an in degree and an out degree. So in this case, the node A, we can call these nodes or vertices. So this can be called as a node or vertex. So it can be called either a node or a vertex, and each node will have an in degree and an out degree. So, in degree is basically the total number of edges that are going into a particular node. An edge is basically um, something which connects one vertex to another vertex. So, if we take, for example, the node M, it has an in degree of 1 because there is one edge coming into the vertex, which is this vertex from L, and it has an out degree of 1, which is because there is an edge going from vertex M to vertex L. And here you can see that basically these are parallel edges because there is one edge coming to M and from L, and another edge going from M to L. So this is called as parallel edges, and this is called as a self loop because um, there is an edge going from R, and that same edge is also coming into R. So in other words, one edge is contributing to the in degree and out degree of the same vertex. So there is one note that we need to consider. So the sum of in degrees of all nodes must be equal to the sum of out degrees of all nodes in a valid graph. And that's the reason why self loop, when a particular vertex has a self loop, the in degree and the out degree would be increased by 1. So both would be increased by 1. So now coming to undirected graphs. Undirected graphs are called as undirected graph or non-directed graph or graph. All of them represent undirected graphs. And here each vertex doesn't just have in degree out degree, it has just degree. It's called as degree, which means the total number of edges connecting that vertex to any other vertex. So in this case, looking at vertex 10, it has a degree of 2 because there are two edges going from vertex 10, or like which are connecting vertex 10 to other vertices. And self loops are not allowed in an undirected graph. And a path is basically a collection, a set of all vertices from a source node to a destination node. In this case, the source node or the source vertex would be vertex 3, and the destination node would be vertex 5. So what are all the nodes from on the path from vertex 3 to vertex 5? It's going to be 3 to 10 to 9 to 5. So how would you travel uh, to vertex 5 starting at vertex 3? So you would start at 3, then go to 10, then go to 9, and then finally go to 5. So that's the path. And coming to simple digraph, a simple digraph is nothing but it's a directed graph without any self loops or any parallel edges. And now we'll be looking at cycles. So a cycle is nothing but a path, but it's circular in nature. So for example here, uh, we look at this path where the source node is 9 and the destination node is also 9. So that's the reason it's called a circular path, because the source and the destination node end up being the same. So you start at 9 and then you go to 5 and then to 10, and then once again you inevitably end up coming back to the same exact node that you started with. So that's the reason we see a cycle over here. And another example is here with an undirected graph. So if we start at 9, we can go to 10 and then to 3, and then again we are inevitably coming back to 9. See, one thing to note here is that in a cycle, between the source node and the destination node, there should not be any duplicate nodes. So for example, there couldn't be like 9, 10, and then 3, and then 10, and then 3 and 9. So because you're repeating 10 twice, and 3 as well. So between the source node and the destination node, only these two can be repeated, but nothing in between. None of the nodes can be repeated, or so there cannot be any duplicates in between. So now let's move on to directed acyclic graphs. So they're basically directed graphs without any cycles. Acyclic means no cycles. So directed graphs without any cycles. So here if we look at, let's say the source node is 10, we can go to 9 and then to 5, but we cannot come back to 10. So there's no cycle. And all binary trees, for example, are directed acyclic graphs. So here, let's say we go to 10, we start from 10 and then go to 5 and then to 3. There's no way we are coming back to 10. There's no mechanism that allows us to do that. So all binary trees are inevitably DAGs. Thank you all for watching this video. See you all in the next video. Thank you.